All right, so let's talk about absolute value. Okay, so the definition of absolute value is this. So the absolute value of x is equal to x if x is greater than or equal to 0. Okay, so absolute value of x is equal to the opposite of x if x is less than 0. So let's look at some examples. So, for example, take the absolute value of 5. 5 is greater than or equal to 0. So the absolute value of 5 is just equal to 5. Try the absolute value of 3. 3 is greater than or equal to 0. So the absolute value of 3 equals 3. Let's try 0. 0 is equal to 0. So the absolute value of 0 equals 0. Let's try some more examples. Take the absolute value of negative 3. Negative 3 is less than 0, so we will use the bottom part of the definition. So this time x is negative 3. So the absolute value of negative 3 is equal to the opposite of negative 3. So minus 3, like that. Opposite of negative 3 is positive 3. Let's try another. Absolute value of negative 8. Okay. Negative 8 is less than 0, so we're going to use this part of the definition. So the absolute value of negative 8 is the opposite of negative 8. The opposite of negative 8, which would be positive 8. So that seems a little abstract. It's really a lot easier if you think about it. The absolute value of a positive number, or 0, is just equal to that number. The absolute value of a negative number makes that negative number positive. All right, let's solve some simple absolute value equations. So I want to solve this equation for x. Okay, you have two possibilities. So one possibility is that everything inside of this absolute value, this x, is a positive number. If this is positive, then by the definition I gave you a few minutes ago, if everything inside of here is positive, then it stays the same. So we'll just have an x equals 5. So that's one solution. So if I plug 5 in for x, the absolute value of 5 is 5. That's true, so that's a solution. And the second possibility is that everything inside of here could be negative. If everything inside of here were negative, remember by the definition I gave you, then the absolute value of everything inside of there would be the opposite of what's inside of it. So if x were negative, then the absolute value of x would be negative x, or the opposite of x. So we have negative x equals 5. Solving that for x, dividing both sides by negative 1, we get x equals negative 5. Okay. And we can check that that's a true solution. If I put negative 5 in for x, the absolute value of negative 5 is 5. Okay, so it's really kind of simple. If you have an absolute value, you're going to have two different solutions. We can have the positive solution or the negative solution. So the absolute value of 5 is 5, and the absolute value of negative 5 is 5. Let's try another. So let's solve this equation. Absolute value of x equals 7. So again, we'll have two possibilities. The possibility where x is positive, in that case, the absolute value of a positive x would just be x. So x equals 7. Or the other possibility is that x is negative. If x is a negative number, then the absolute value of x is the opposite of x. So it would be negative x equals 7. Solve that, and we get x equals negative 7. So two solutions. Absolute value of 7 is 7. Absolute value of negative 7 is 7. Okay. Let's try another example. Absolute value of x equals -4. So let's think about this. The absolute value of a number will make that number positive. So is there any value of x we can take the absolute value of and get a -4? No, of course not. Your answer will always be positive. So this has no solution. If I take the absolute value of any number, my answer will always be positive. There's no way to get a negative number. All right, let's solve some more interesting absolute value equations. Okay, so the first one, we have 3 times absolute value of x plus 7 is equal to 19. We want to find all the solutions to this equation. So the strategy should be to isolate the absolute value on one side of the equation. So we're going to solve for the absolute value of x. So step number 1, subtract 7 from both sides. Now we'll get 12. We're going to get rid of the 3, so I'm going to divide both sides by 3. This means multiply here, 3 times absolute value of x, so divide both sides by 3. I get the absolute value of x is equal to 4. Okay. And then we know that this has 2 solutions. X equals 4, or x equals -4. And we can check those solutions, just plug it in. If I plug in a 4 here, absolute value of 4 is 4. 3 times 4 is 12. 12 plus 7 is 19. So that's good. Plug in -4. Absolute value of -4 is 4. 3 times 4 is 12. 12 plus 7 is 19. So those are both solutions. Okay, let's look at the second one. Okay, the absolute value is already isolated by itself. So we're going to go ahead with our 2 possibilities. So possibility 1 is that everything inside of here is positive. If that's the case, it stays the same. So x plus 5 equals 3. That's one possibility. Second possibility is that everything inside the absolute value is negative. If it's negative, then the absolute value of everything in there is the opposite of everything in there. So the other possibility looks like this. So again, if everything inside the absolute value turns out to be positive, then the absolute value of everything in there is just what it is, x plus 5. If everything inside the absolute value turns out to be negative, then the absolute value of everything in there is the opposite of everything that was in there. All right, so let's solve this one first. Just subtract 5 from both sides. So x equals -2. That's one solution. Solve this one. I'm going to multiply both sides by -1. So x plus 5 equals -3. Solve this one. I'm going to subtract 5 from both sides, get x equals -8. So 2 solutions. Let's check, make sure they work. So if I plug -2 into this equation, -2 plus 5 is 3. Absolute value of 3 is 3. Plug -8 into this equation. -8 plus 5 is -3. Absolute value of -3 is 3. So that works. Okay, next equation. So I'm going to isolate the absolute value. So I'm going to subtract 1 from both sides. That's 8. I'm going to divide both sides by 4. All right, so now I have 2 possibilities. Possibility 1, everything in there is positive. So I will have x minus 3 equals 2. The other possibility is that everything in there is negative, in which case we will have x minus 3 equals -2. Okay. I kind of skipped a step right here from here. Over here, I showed you the negative on that side. But then I multiplied both sides by -1, got the negative over here. So I kind of skipped that first step. All right, I'm going to add 3 to both sides. 2 plus 3 is 5. So there's one solution. Add 3 to both sides here. -2 plus 3 is 1. There's my second solution. So either x is equal to 5 or x could be equal to 1. Let's check, make sure those work. So if I put in a 5, 5 minus 3 is 2. Absolute value of 2 is 2. 4 times 2 is 8. 8 plus 1 is 9. That works. Plug in a 1. 1 minus 3 is -2. Absolute value of -2 is 2. 4 times 2 is 8. 8 plus 1 is 9. So that works. All right, let's try this example. All right, so again, our strategy is to isolate the absolute value by itself on one side of the equation. So I'm going to subtract 1 from both sides. That leaves me with 2 times absolute value of 3x minus 5 equals 12. Now I need to divide both sides by 2. That leaves me with absolute value of 3x minus 5 equals 6. Okay, so goal number 1 successfully completed. I've isolated the absolute value. Now I've got to think about my 2 possibilities. So the first possibility, everything in there is positive. So the absolute value of everything would just stay the same. So 3x minus 5 equals 6. Second possibility, everything in here is negative. In that case, absolute value of everything in there would be the opposite of everything in there. So negative 3x minus 5 equals 6. All right, solve this equation. I'm going to add 5 to both sides. X equals 11. Divide both sides by 3. I get x is 11 over 3. Come over here. I'm going to multiply both sides by -1. So I will have 3x minus 5 equals -6. So oftentimes I'll skip this step here. I'll just say that 3x minus 5 is equal to 6, or 3x minus 5 equals -6. I'm going to add 5 to both sides. I get 3x equals -1. Divide both sides by 3. X equals -1/3. So there's one solution. Here's the other solution. Let's check and make sure those actually work. So I'm going to plug 11 over 3 into this equation. 3 times 11 divided by 3 is just 11. 11 minus 5 is 6. Absolute value of 6 is 6. 2 times 6 is 12. 12 plus 1 is 13. So that one is good. Let's try this one. -1/3. So 3 times -1/3 is -1. -1 minus 5 is -6. Absolute value of -6 is 6. 2 times 6 is 12. 12 plus 1 is 13. That one works. All right, let's try to solve an absolute value inequality. Okay. So again, we're going to have 2 possibilities. Possibility 1 is that the x is positive. If the x is positive, then the absolute value of x is just x. So we have x is less than or equal to 3. That's one possibility. And second possibility is that the x is negative. If the x is negative, absolute value of x is the opposite of x. So we have negative x is less than or equal to 3. If I solve this one, if I multiply both sides by -1, I'll have an x and I'll have a -3. Remember, with inequalities, if you multiply or divide both sides by a negative number, it flips the way the inequality points. So I'll have that. All right, so I have x is less than or equal to 3. And x has to be greater than or equal to -3. So let's think about this on a number line. So here's negative 3. Here's 3. It's less than or equal to, so I'm going to use a closed circle. 3 and negative 3. All right, so my solutions are all the x values that satisfy both of these conditions. So all the x's that are both less than 3 and greater than negative 3. So numbers less than 3 are these numbers all the way out this way forever. Numbers that are greater than negative 3 are all these numbers out this way forever. But which numbers satisfy both of those conditions? It's the numbers in between negative 3 and 3. Okay. So all the numbers in between negative 3 and 3, including negative 3 and 3, are both less than or equal to 3 and are greater than or equal to negative 3. All right, so let's think about that with the original figure. So if you picked any number in between here, say 0, if I put a 0 again, the absolute value of 0 is 0, that's less than 3. If I chose maybe a 2, absolute value of 2 is 2, that's less than 3. If I chose negative 2, absolute value of negative 2 is 2, that's less than 3. So you can see any of these numbers that I pick in between here satisfy this inequality. And let's think about numbers out here. Say a 4. Absolute value of 4 is 4. That's not less than 3, so that can't work. If I chose negative 4, absolute value of negative 4 is 4. 4 is not less than 3, so these numbers don't work. The only x values that satisfy this inequality are the ones between negative 3 and 3, including the negative 3 and 3. All right, so let's see if we can solve this inequality. So absolute value of x is greater than or equal to 5. Okay, so again, two possibilities. Possibility number 1 is that the x is positive, so the absolute value of x would just be x. 5x is greater than or equal to 5. Or the other possibility is that x is negative, in which case the absolute value of x would be negative x. It's greater than or equal to 5. Again, to solve this, I'm going to multiply both sides by negative 1. Remember to change the way that points, and I get x is less than or equal to negative 5. Now let's think about this on the number line. I have negative 5, 5. Those numbers are included in my solution. All right, so this time I want any x value that's either greater than or equal to 5 or less than or equal to negative 5. So numbers that are greater than 5 are out this way. Numbers that are less than or equal to negative 5 are out this way. And let's make sure that that makes sense. So if I pick a number between negative 5 and 5, let's say 4. Absolute value of 4 is 4. That's not bigger than 5, so that's not a solution. Let's try negative 4. Absolute value of negative 4 is 4. That's not bigger than 5. So nothing in here is a solution. Numbers out on the tails, let's say 6. If I put a 6 in, absolute value of 6 is 6. That really is bigger than 5. So you can see all those numbers out that way would be solutions. If I put in a negative 6, absolute value of negative 6 is 6. That's greater than 5. And you can see that all the numbers out this way are solutions. All right, so let's think about the difference between these two. So this one, your x is less than a number. Notice that I wrote and right here. So if you have the absolute value of x is less than or equal to a number, both of these conditions have to be satisfied. Your solutions are only the x values that satisfy both of these. And that will be things or numbers between these two values. Okay, so less than or equal to is an and statement, and it ends up being numbers in between. Okay, absolute value of x is greater than, notice this is an or. So you only have to take x values that satisfy either of these conditions. It can satisfy this one or this one. Notice these are out on the tails. So absolute value of x is greater than gives you answers out here on the tails of the number line. All right, here's two fun inequalities to solve. So let's give them a whirl. Okay, again, our strategy is to isolate the absolute value. So I'm going to subtract 1 from both sides. Going to divide both sides by 2. 2 is positive, so I don't have to change the way that points. I have x plus 3 is greater than 4. All right, two possibilities. Either x plus 3 is positive, in which case it stays the same. Or the other possibility is that x plus 3 is negative, in which case we will make it the opposite. Okay, notice this is greater than. Absolute value of x plus 3 is greater than, so this will be an or statement. All right, subtract 3 from both sides and I get x is greater than 1. Or multiply both sides by negative 1 and I will get x plus 3. Remember to change the way that points. Subtract 3 from both sides and I get x is less than negative 7. So let's make sure that our solutions make sense after we graph them on a number line. So I have negative 7 and I've got 1. This is strictly less than, so the 1 and the negative 7 will not be included, so I'm going to use open circles. All right, this is an or statement, so I want to graph all the x values that are either greater than 1, so out this way, or less than negative 7, which will be out this way. All right, now there's a lot of stuff going on here, so let's check and make sure we didn't mess anything up. Let's check these solutions. So let's pick a number in between negative 1 and 7. Let's say 0. If I pick 0, it shouldn't work. All right, so put in a 0. 0 plus 3 is 3. Absolute value of 3 is 3. 2 times 3 is 6. 6 plus 1 is 7, and 7 is not greater than 9. Let's try maybe negative 6. Negative 6 should not work. If I put in a negative 6 plus 3 is negative 3. Absolute value of negative 3 is 3. 2 times 3 is 6. 6 plus 1 is 7. Doesn't work. We're claiming that 1 doesn't work because there's an open circle. So let's put a 1 in. 1 plus 3 is 4. Absolute value of 4 is 4. 2 times 4 is 8. 8 plus 1 is 9. And 9 is not greater than 9. All right, let's check some that should work. So let's put in a 2. 2 should work. 2 plus 3 is 5. Absolute value of 5 is 5. 2 times 5 is 10. 10 plus 1 is 11. That really is greater than 9, so that works. Let's try negative 8. Negative 8 should work. Negative 8 plus 3 is negative 5. Absolute value of negative 5 is 5. 2 times 5 is 10. 10 plus 1 is 11. 11 really is greater than 9, so we have that one right. Hey, always check your answers and think about what you're doing. Make sure that your answers make sense. Now let's try this one. So again, strategy is to isolate the absolute value. So I'm going to subtract 1 from both sides. I'm going to divide both sides by negative 3. But remember, if you divide by negative, you have to flip the way this points. So I will have absolute value of 2x plus 10 is less than or equal to 4. Okay. Two possibilities. Either 2x plus 10 is less than or equal to 4. This is a less than, so this should be an and statement. Absolute value of my x is less than, so it's and. And negative 2x plus 10 is less than or equal to 4. Alright, so solve this one. I'm going to subtract 10 from both sides. 2x is less than or equal to negative 6. Divide by 2. X is less than or equal to negative 3. Okay, over here, multiply both sides by the negative 1. 2x plus 10 is greater than or equal to negative 4. Remember, you have to flip it because you multiply by negative 1. I subtract 10 from both sides. Negative 14, divide by 2, and I get negative 7. All right, so let's graph the solutions on a number line. I need a negative 7 and a negative 3. Should be closed circles. This is an AND statement, so it has to satisfy both of these. So I need x values that are both less than or equal to negative 3 and greater than or equal to negative 7. So those would be right in the middle. Those in there. Let's check. Let's put in maybe negative 5. If I put in a negative 5, that should work. 2 times negative 5 is negative 10. Negative 10 plus 10 is 0. 0 times negative 3, that goes away. 1 is really greater than or equal to negative 11, so that works. Let's try 1 out here and make sure it doesn't work. So I'm going to put in negative 2. 2 times negative 2 is negative 4. Negative 4 plus 10 is 6. Absolute value of 6 is 6. 6 times negative 3 is negative 18. Negative 18 plus 1 is negative 17, which is not really greater than or equal to negative 11, so it should not work. So that's good. Check one more. Let's put in negative 8. Negative 8 should not work. Let's make sure it doesn't. 2 times negative 8, negative 16, plus 10 is negative 6. Absolute value of negative 6 is 6. 6 times negative 3 is negative 18. Negative 18 plus 1 is negative 17, which is not really greater than negative 11, so that does not work, and we can be confident we got the correct solution. All right, let's graph an absolute value function. So this is a very basic, simple one. All right, so I have f of x equals the absolute value of x. So anytime we want to graph a function, we can just plug in any value we want for x, as long as it works. All right, so if I plug in 0 for my x, absolute value of 0 is 0. I'll have this point. All right, if I plug in 1, f of 1 would be the absolute value of 1, which would be 1. If I plug in 2, absolute value of 2 is 2. Absolute value of 3 is 3. Absolute value of 4 is 4. And you see that you get this straight line with a slope of 1. Any number you plug in for x, if I plug in 2.5, absolute value of 2.5 is 2.5, so I just get this straight line. Now let's go this side. If I plug in negative 1, absolute value of negative 1 is 1. Absolute value of negative 2 is 2. Absolute value of negative 3 is 3. Absolute value of negative 4 is 4. And you see that you get a straight line with a slope of negative. Okay, so absolute value function gives you this nice V shape. All right, let's graph all the solutions to this inequality. Okay, so let's start out by plotting some points. So if I plug 0 in for x, 0 minus 3 is negative 3. Absolute value of negative 3 is 3. And notice there's not an equal sign, it's strictly greater than, so I'm going to use an open circle. I plug in 0, I've got 3. Let's plug in a 1. 1 minus 3 is negative 2. Absolute value of negative 2 is 2. Again, I'll use an open circle. If I plug in a 2, 2 minus 3 is negative 1. Absolute value of negative 1 is 1. If I plug in a 3, 3 minus 3 is 0. Absolute value of 0 is 0. So I see I'm getting this line. All right, if I plug in a 4, 4 minus 3 is 1, absolute value of 1 is 1. Plug in a 5, 5 minus 3 is 2, absolute value of 2 is 2. Plug in a 3 or a 6, 6 minus 3 is 3, absolute value of 3 is 3. And you see in that line. So again, I've used a dotted line and open circles because it's strictly greater than. Okay, so I want to plot all the points that are solutions to this inequality. So I want all the points whose y value is greater than this. So those will be all these points in this area. Let's check and make sure that's actually true. So I'm just going to pick a point in here. Let's say 3, 2. Okay, so is 3, 2 a solution to this inequality? So if I plug 3 in for x and 2 in for y, is that true? Is 2 really greater than 3 minus absolute value of 3 minus 3? So 3 minus 3 is 0, absolute value of 0 is 0, and 2 really is bigger than 0. So all these points are solutions. Let's check and make sure the points out here are not solutions. So I'm just going to pick one. Let's say this point. Okay. So if this point is 5, 0, so I'm going to plug 5 in for x and 0 in for y. So is 0 greater than absolute value of 5 minus 3? So 5 minus 3 is 2. Absolute value of 2 is 2. And 0 is not bigger than 2. So that is not a solution. And let's check just one more. Let's do 0, 0. So if I plug in 0, 0, 0 minus 3 is negative 3. Absolute value of negative 3 is 3. 0 is not bigger than 3. So that is not a solution. So we've graphed all the points that are solutions to this inequality. All right, let's talk about distance between numbers. So suppose I ask you for the distance between 7 and 4. How would you find the distance between those two numbers? Well, you would subtract, right? So you could do 7 minus 4, and you would get 3. So the distance between 7 and 4 is 3. Okay, you could also do 4 minus 7, and that would give you negative 3. But we always want distance to be positive. We don't want to have a negative distance. So what we would say is the absolute value of 4 minus 7, which would give us absolute value of negative 3, which would give us a distance of 3. Up here, if we just said the absolute value of 7 minus 4, it wouldn't change anything, because that would just be the absolute value of 3, which would be 3. So you can always find the distance between two numbers by subtracting in either order and taking the absolute value. All right, so let's see if we can write an absolute value expression that encapsulates these words. All right, so I want all x values whose distance from 5 is less than 3. All right, so the first part of this, all x values whose distance from 5. So how do I find the distance between x and 5? Well, I subtract, and I take the absolute value. So the absolute value of x minus 5 is the same thing as saying the distance between x and 5. All right? And I want that distance to be less than 3. So I just do that. So this says that all x values whose distance from 5 is less than 3. Let's graph this on a number line. Or first of all, let's work it out. So two possibilities. We have x minus 5 is less than 3. And x minus 5, negative x minus 5 is less than 3. All right, if we work these out, add 5 to both sides, I'll get x is less than 8 and multiply by -1, have x minus 5 is greater than -3. Add 5 to both sides, x is greater than 2. Okay, so let's put that on a number line. So I have 2, 8, and I want to graph all the numbers that are both less than 8 and greater than 2. So those numbers would be between 2 and 8. Halfway in between 2 and 8 is 5. Okay, so make sure that the numbers we have graphed here make sense with what we were saying. So all the shaded, these are all the x values that I'm talking about. So I want to shade all the x values whose distance from 5 is less than 3. So is that true? Take this number right here. Maybe this is a 7. Okay, is the distance between 5 and 7 less than 3? It is. That's why I've shaded the 7. What about maybe the 4? Is the distance between 4 and 5 less than 3? It is. So I've got 4 shaded. So you can see every number that I've shaded in, its distance from 5 is less than 3. So if I go 3 this way or 3 that way, all the numbers in between there, their distance from 5 is less than 3. All right, I've given you 3 practice problems up here to work on. So find me the solutions to these 3 and graph those solutions on the number line. Pause the video, work these out, and then we'll go over the answers. All right, so let's have a look at the first one. So first thing to do is isolate the absolute value. So I'm going to add 3 to both sides. It's greater than or equal to 15. Divide both sides by 5. Okay, break it into our 2 possibilities. So either 2x plus 7 is greater than or equal to 3. It's greater than, so this will be or 2x plus 7, the opposite of 2x plus 7, is greater than or equal to 3. All right, subtract 7 from both sides. I get -4, divide both sides by 2. X is greater than or equal to -2. Or multiply both sides by -1. Remember to flip the way this points. 2x plus 7 is less than or equal to -3. I'm going to subtract 7 from both sides. 2x is less than or equal to -10. Divide both sides by 2. X is less than or equal to -5. Okay, let's put our solutions on a number line. So I have -5, -2. Should be closed circles because I have the equal sign there. All right, so I want all these numbers that are greater than or equal to -2. Those are up this way. Or they can be less than or equal to -5. All right, always check and make sure your solutions make sense. So let's put in maybe a -3, and that should not work. So if I put -3, that's -6 plus 7 is 1. Absolute value of 1 is 1. That's 5. 5 minus 3 is 2. 2 is not greater than or equal to 12. So that should not work. Let's try a 0. Make sure 0 works. So if I put in 0, that'll be the absolute value of 7. Times 5 is 35. 35 minus 3 is 32. Definitely greater than or equal to 12. So that's good. Let's check over here. Let's put in a -6. So if I put -6, that's -12. Plus 7 is -5. Absolute value of that is 5. 5 times 5 is 25. 25 minus 3 is 22, which is greater than or equal to 12. So we can be confident we got that right. All right, the second one. Let's subtract 2 from both sides. Divide both sides by -4. Remember to change the way the inequality points. -2. All right. Let's think about this. Can the absolute value of anything be greater than -2? Is that possible? No, you can't, because the absolute value of anything will always give you a positive answer. So that has no solution. That is impossible. All right, let's try the third one. So I'm going to subtract 3 from both sides. 1 minus 3 is -2. Okay, let's think about this one. The absolute value of anything greater than or equal to -2. So remember, the absolute value of anything will make that positive. So this side will always be positive. So no matter what I put in for x, this side will always be greater than or equal to -2. Has to be, because anything positive is greater than -2. So I can plug anything in for x. So all real numbers are solutions. All right, so here's 2 more practice problems for you. I want you to graph y is less than or equal to the absolute value of x plus 3. And here, I want you to write an absolute value inequality to express all the x values whose distance from 13 is greater than or equal to 4. And then I want you to graph that on a number line for me. So pause the video, work those out. All right, so let's try this one. Let's make a graph. That's what x is, my y's. All right, if I plug in 0 here, absolute value is 0, 0, 0 plus 3 is 3. If I were to plug in a 1, absolute value of 1 is 1, 1 plus 3 is 4. If I plug in a 2, 2 plus 3 is 5. If I plugged in a 3, 3 plus 3 is 6. So we get this. Over here, if I plug in -1, absolute value of -1 is 1, 1 plus 3 is 4. And you probably realize what's going to happen. Absolute value of -2 is 2, 2 plus 3 is 5. So you see we get that. There's an equal sign here, so I'm using solid or closed dots, solid lines. I want to graph all the points whose y value is less than that. So these will be things below the line. This is really hard to shade in on the board. Okay, let's just check one, make sure it really works. So let's pick maybe 3, 1. Let's see if 3, 1 actually works. So if I plug a 3 in for x, 3 plus 3 is 6, and 1 really is less than 6, so that works. Let's pick one up here, make sure it doesn't work. Let's go with this guy. So this point is 0, 6. So if I plug 0 in for x, 6 in for y, is 6 really less than 0 plus 3? It's not, so that's not a solution. So we can be confident that we got the right answer. All right, over here, write an absolute value inequality to express all x values whose distance from 13. So how do I find the distance between x and 13? Well, I subtract, and I take the absolute value. And you could have these switched. You could have 13 minus x, absolute value. All right. To express all the x values whose distance from 13, so we've got that, is greater than or equal to 4. All right, so we did that. All right, now we want to show this on the number line. So let's work out the 2 possibilities. Either x minus 13 is greater than or equal to 4. This is greater than, so this will be an or statement. Or the opposite of x minus 13 is greater than or equal to 4. I'll work it out. Add 13 to both sides. I get x is greater than or equal to 17. Or multiply by -1 on both sides. X minus 13. Remember to flip this. Less than or equal to -4. Add 13 to both sides. And I get 9. So let's put that on the number line. My points are 9 and 17. There's an equal sign, so I'm going to use closed circles. This is an OR statement. So I want all the numbers that are either greater than or equal to 17. That's out this way. Or less than 9. Let's go out this way. Let's just check and make sure we got it right. So let's plug in maybe 20. Or let's plug in 18. Let's get really close here. So if I put 18 in, 18 minus 13 is 5. And 5 really is greater than 4, so that works. Let's try maybe an 8. 8 minus 13 is -5. Absolute value of -5 is 5. That's bigger than 4, so that works. Let's just check one in here. Let's go with 10. 10 minus 13 is -3. Absolute value of -3 is 3. 3 is not greater than 4, and it shouldn't be because we don't have it shaded in. So we can be confident we got the correct answer.